we are given a cubic function, and it is a positive cubic because the coefficient of x cubed in this case is positive 1, so it will look something like so. Right, so that's our f of x. And the question is asking us to find the gradient of this graph when x equals 4. So alarm bells ringing, it's asking for the gradient. Well, we can find the gradient function using differentiation. So a reminder what that means. We denote the gradient function by f prime of x, so that little apostrophe next to f, the first derivative. And the derivative of f of x, we can break it down into its terms, so tackle one at a time. We can do that for this polynomial. So the derivative of x cubed, we take the power of 3, multiply it out the front to give 3. Our variable stays the same, except we now subtract 1 off of the power. So that becomes to the power of 3 minus 1, or in one step, to the power of 2. And that rule is in your formula book, so it's the derivative of a polynomial term. Let's do the same with the second term. So taking the power, multiplying it out the front, minus 2 times 2 gives minus 4. Our variable stays the same, and we subtract 1 from the power, so 2 becomes 1. And in correct notation, we don't need to denote the power of 1. Right? It is implied. And lastly, the derivative of plus 5. So the derivative of a constant is 0. And how we know this is two ways. You could consider the graph of y equals 5. Right, so there's 5 down there. It would be a flat line. So the gradient of a flat horizontal line is 0, and the derivative means the gradient. Alright, so plus 0. Or, if you'd like to still use the rule, you can. It's just a little bit different, where it's actually 5x to the power of 0. Right, because x to the power of 0 is 1, so I haven't changed anything. We take the power, multiply it out the front. 0 times 5 gives 0. Right, so either way works. I personally just like to remember that the derivative of a constant is 0. Okay, so let's reread the question. Have we answered it? No. Right, we found the gradient function, and what this does is for any input x, it outputs the gradient of the original function. So we are given the input x, and we are looking for the gradient. So in for x will go 4, and we will get the gradient is our output. Right, so let's substitute that in now. So the gradient when x equals 4 is equal to 3 times 4 squared minus 4 times 4. 4 squared is 16, also like a dairy. 16 times 3, 16, 32, 48. Minus 16 gives us 32. So the gradient at x equals 4 of f of x is equal to 32. Right, and getting the correct solution would give us achieved. Right, so I mean that's the question done, but I'll show you how you can do it on your calculator as well. This is more to check, right? Do show your calculus working for the calculus paper. But you can go to graph. You do need to turn this setting on though, so it's shift menu to get to setup, and you go down to derivative and turn derivative on. Exit. Now we can graph it, so x cubed minus 2x squared plus 5, execute. We can hit draw. So here's our graph. I'm a bit zoomed in. Oh, there we go, scrolling up. So it's a cubic like we expected. And now to get the gradient, since we turned the derivative on, we can hit F1, which is trace, and see we get an x value, the y value, like normal, but we also get dy by dx, so that is the gradient. So what I can do is I can hit, what was it, x equals 4, so I type 4, hit execute. So when x is 4, the y value is 37, but the derivative, right, which we turned on, the gradient, is 32, which is what we got. So, pro tip, give yourself the mark, save your marker some time. Don't actually do that, but, be confident in your solution.